And we are live again with the stream. It is day 3 of our launch week. Today with the CTO and the mastermind behind WunderGraph, Dustin, who somehow holds all the tech together. Hey, Dustin, what did you have for lunch today?
First of all, nice to be here. Thanks having me. Live from Germany, the same as you, Jens. And what I had for lunch? Actually, a pancake.
Pancake.
With pancake and classic Cola Light.
Pancake with bacon. No marmalade or something.
Nothing. Just super dry.
Cool. Yeah, it's launch week of the hub. How do you feel?
To be honest, awesome. It was such a big team effort. It took us 2 months. And that includes planning, preparation, execution, and I think it was a huge success. We accomplished everything we wanted to accomplish. And see it yourself. Go to hub.wundergraph.com. And so overall, super exciting, super proud of the team. And yeah.
How does it feel to be CTO of a company that once was a handful of founders and founding engineers, and now it feels like it actually is a company? Like, if you reflect back on a couple years ago, like, how does it feel to have built this kind of team and tech and everything?
That's a big question. I'm not sure how much time do we have. No, just kidding. I think when you start a startup, and you're pretty much very hands-on in the beginning, because you want to build it, you want to prove the point, and the more people join the company, I think your role change over time. You need to make people autonomous. You need to make yourself redundant. You need to teach people. You need to educate people. Yeah, bringing them to a state where you think like they can run that themselves in the same quality and the same vision that you have anticipated in the beginning of starting the journey. So I think, and so if I think today we are 16 engineers, and it's not so much about tech anymore. It's about really creating a company.
Coordination.
It's about coordination, exactly. And
that's my slogan. I had to say it so many times.
That was not prepared, but actually it was a good match. It's about coordination, and creating the right engineering culture that embrace the right values, and that you actually can move forward in what you're doing.
Yeah. It's funny, the problems we solve for our customers: collaboration, governance, code reviews. Yeah, we are slowly becoming them, and we run into the same issues, right?
To be honest, like in the beginning, we were, I'm not sure if it's super, if you can compare, but we are a small monolith. And then we adopted Federation, and we split out our team into our company into smaller teams and component teams. Now we have our second product, Hub, which becomes a bigger subgraph. So you can also see it like this. And now we have the coordination problem. Yeah, exactly.
We now have sub teams, and our agents there, Nathan, David. Cool. So we don't really have an agenda, but we also have an agenda, because our agenda is to not have an agenda and to just chat and whatever. I'm just curious. Like, we're on stream, so I can put you on the spot. How does it feel to have a crazy person like me side by side, who keeps changing their mind, who keeps having like new new ideas. Like how is life at WunderGraph?
I mean, I'm here for more than 4 years, so there must be something that you did right. No, just kidding. I think it's a combination of us, of all founders. Like you have great ideas, then you put them into one room together. We figure out the things, and we reevaluate on the things. We pivot in multiple directions. We build POCs. We talk to our customers. I think this is the setup you need. You need to be successful. Yeah, this is the way I would describe it. Like, yeah.
By the way, why are you wearing the same shirt today?
That was on purpose, to be honest, and it was not dirty. Yeah,
It was the first one you could grab from your.
exactly. I like it. It's great. It's great swag that we got from Paris last year on the API conference, and I like it very much. Yeah, I think it's actually not the same as yours. I think you have the pullover. It's a different variant, but yeah.
Cool. Yeah, let's slowly talk a little bit about Hub, but first, I did this with the other people I had on the stream, and I'm just curious. When we started with Federation, you were the person who kind of bootstrapped Cosmo, and I would kind of make a case that you didn't have the craziest understanding of Federation back at the time. It was more like you were more concerned about the infra and setting up everything. And over the last couple of years, how has your perspective on Federation and on our customers and how they use Federation, how has it changed, and how has your point of view evolved over, like, what is Federation, and how do people use it? What kind of problems do they solve with it?
I mean, in general, like GraphQL Federation is how many years old? 8?
I guess more than 7.
Yeah, so I would say it's boring tech, and it's for good reason. It solves a problem of distributing, of building a data pipeline, of creating an API surface that can be consumed by multiple consumers, and where you can build up a data structure that makes sense. So over the last couple of years, what we have observed is also is like that nobody was trying to solve the problem of collaboration. Like everybody knows what Federation is trying to solve. Like you have a monolith, you want to split it out in multiple teams for scalability reasons. But afterwards, what are the drawbacks of that approach, of this implication? Is like you need to bring the people together in order to build a coherent, semantically right graph, right? You need to encourage collaboration, discussion on how API design should be done in the company. But nobody actually was trying to solve it. And I think we discussed it, I think a few weeks before, like, and we also got feedback from our customers that they tries to design APIs in Slack threads, in Miro boards, and I'm still surprised that nobody was trying to solve that problem. And then we build, now we start to build Hub, and we got amazing feedback from our customers that actually there was absolutely need to solve that problem. We want to bring people together onto one platform, streamline the requirements, like the step of what actually needs to be implemented for that use case, collaborate on API design, then reflect on the changes, and also to understand like if those changes will break anything in the wild, on the client side, and then also bring governance into the game, like who actually own that particular piece of the federated graph. And if you would need to do it alone in the company without Hub, you would have endless alignment meetings. you would need to ensure quality by establishing guidelines and another alignment meeting. And now we're trying that with Hub, and it's just the start of the journey. And yeah.
At the beginning of your answer, you said splitting the monolith. Is Federation really that helpful in splitting the monolith?
Only on the backend side. Like if you want to scale it, if you split it up into multiple domains to allow independent collaboration on the supergraph. But on the consumer side, you don't want to split it out. You want to still consume one single API. That's the magic of Federation, I would describe. For the consumer side the consumer side doesn't care about where the data is coming from. They are interested in a clean, semantically right-shaped API surface.
But how do you get a clean? How do you create a supergraph that's actually following your intent when your tools are subgraphs and composition? Like,
yeah, that's a good question. Like in the traditional setup, you're starting from the bottom, from each individual team is trying to implement or is trying to solve a specific use case that is maybe driven by a consumer. And I think this is the wrong approach. You always should start from a left side, from a consumer perspective. So the consumer should define what data in what shape it needs to implement their use cases in the best possible way. Now, can you achieve that? You need to establish a workflow where you start to design a query that can fulfill the consumer contract, and from that point on, you distribute that to new subgraph or existing subgraph. And this is essentially what I described is the workflow we have implemented in Hub.
Isn't it crazy that this didn't exist? Like in retrospect, imagine you are a big bank and you want to enable a new query. And to make this query work, it's a complex query. You actually need to change 3 subgraphs. If you don't have Hub, how do you actually get to the point that all 3 teams know exactly what to do?
I think it's a classic silo issue. I think if I would need to describe it, how it worked before is people have alignment meetings. A product owner comes with a requirement, and then they figure out the dependencies of that query. Contact every tech lead or team lead to a new meeting, and they're drawing that on a Miro board, and then understanding what each team needs to contribute. And you can already imagine how painful that process is to actually to do.
But you know, even if you take away the people and we're just talking about the tech, imagine you have 100 subgraphs and you have a query that currently fails, and now you need to change 3 subgraphs so that the query doesn't fail anymore. If you are a single person and you own all subgraphs, okay, maybe you can somehow imagine what field goes where and how will the query in the end work, because you kind of need to think about, okay, I want to have this query. What is missing in my subgraphs? I add this, then I run composition, and then the query works. Like, just from a workflow, in retrospect, for me, it is absolutely crazy how anybody ever thought Federation is somehow following the idea of GraphQL, because GraphQL was always for the client. The client can make the query they want. And yeah, I don't know. We didn't have Hub, and it always felt okay. But I'm really wondering how people actually did it, because yeah, I don't know.
No, I completely agree, and this is also just one aspect of the pipeline of the software development lifecycle. Like we just described how to come to that conclusion, how that query should look like based on the requirements. But afterwards, we're talking about how can we enforce that it's according to their best practices and schema policies? Then we are talking about how can we bring people into the discussion who actually owns that type in the subgraph. And then we're talking about how can we understand before merge that this change will have the impact that we anticipated, like also in terms of performance, in you know, like all these little things that that would probably oversight in a process that is not, that cannot be enforced by a platform. Yeah.
And you know, we had this discussion earlier. We were talking about code reviews and AI. And the thing is, I think it's very clear, like the writing is on the wall, that in the future, humans will not create new schema or new queries. Humans will tell an agent that, hey, I have this React component, make me a query. How will the query look like? And if the query doesn't exist, somehow figure out what the query could be. And I think that it's coming. It's so clear. But the next step is you must have governance, especially with AI. And I think this is where Hub kind of scores double, because it is the only way where AI can go on the fast lane, figure out the solution to the problem, like here, schema change, and then humans get a visual canvas. They can understand the changes. They can see what is going on, what will be changed. One other part we have in the proposal view, we can compute the complexity and the query plans for all your existing operations, so you can see and understand, okay, if I move this field around, this is what's going to happen. And I think these kind of things, this will be fundamental to unlocking the AI potential. The other part is, and I'm super proud that the team pulled this off, we have schema ownership. So people, like humans own entities and humans own subgraphs. And if we intend to change them, we can automatically notify them and they can review the changes in the proposal. And I think that is the only way how AI will work in the end, because you can't just say, AI build me APIs, and then you go to bed and you let them do whatever. It's not intentful.
I mean that's a prediction of the current market. Code generation has been solved. However, code reviews will become the bottleneck. And then it's our job on Hub to solve that problem, to enable people making good code reviews. In that case, reviewing API changes and establishing the right guardrails to not lose, to still keep up with velocity, but not lose on quality and governance.
Yeah. And then there's a completely other topic, because everybody is currently trying to figure out, okay, we have agents, we have Claude, we have Codex, we have OpenAI, we have all these agents. And agents in a box are quite powerful. You give them a PDF, they do something on the PDF, and they give you something back. That's cool. But what is even more interesting, I think, is when you can give agents access to real-time information, ideally through APIs. So now you have a new problem. Everybody is thinking about, okay, are we building MCP servers? Do we manually hook up our services? Cloudflare built something like code mode that sits on top of hundreds and thousands of REST API endpoints to search the right REST APIs that help you solve your problem without polluting the context. How do you think about the interaction between, so let's say I'm a big bank and I have like so many APIs. I have databases, I have data lakes, I have SOAP, I have REST APIs, I have everything. How do I give access to my data in a secure and governed way to agents? How do you think about this?
If you talk about democratized data access, I can tell something about that. I mean, a lot of people are already aware of Perplexity. Perplexity is like Google search on steroids. It's able to discover the web and have smart rethink, smart models on top of that. It can give you like insight of what data sources were involved in that research, and even in much more. I think about like one of the big strengths of GraphQL Federation in general is like, if a company is capable of integrating all APIs into that graph, then the real value is, how can I make this data accessible to the whole company? And now imagine someone could just talk to your graph in natural language. And on top of that, imagine you could have a Perplexity interface where you can just ask questions, and our system would then also be able to through what you just described, code generation, you could post-process the data to actually come to a very precise report of your question. So I think this is very powerful. You imagine you can talk English to your graph, and then also post-process the data, and this allows you in the company to get real-time reports of what is going on in your company. I think this is very huge, and that can make a big difference in a company.
Let me play devil's advocate. Why do I need a federated graph for this? I can just have Claude talk to my APIs directly. It can make curl requests, or I can. Yeah, why do I need a federated graph in the middle? What's the point?
Okay. Let's play like this. Imagine you have like REST APIs. You have an API catalog of 1,000 endpoints, and you would need to create structure out of it. So how would you get started? You would index something. It's super hard to actually get a structure out of it. You would need to understand what service is responsible for what entity. Then there are probably multiple entities across these services. You have maybe 4, 5, 6 card definitions. So actually to get to a meaningful foundation that you can carry, that you can get meaningful, that you can actually understand and can pass on to an LLM, this is, I would say, impossible. What you need a common denominator, that is the graph, the graphs that needs to make sense semantically, so that you can build on top of that, if that makes sense.
I think I have never seen a large organization where you have 1,000+ REST API endpoints, and they are so well documented that it is very clear that they always mean semantically the same object or something. You know, one of the good things in GraphQL is you have __ type name, and it's a user. Type name is user, and you have the schema, and the schema says it's a user. And the user has posts. It's a relationship. And you can see that in the schema, relationship from user to posts. And in Federation, you have something even more powerful. You have the entities, not just objects. You have the entities, and everybody agrees on these are our entities, like car and tire and window and whatever. And each entity has one or more keys, the unique identifiers to get such an entity. And then if you have multiple backends, they can agree that, I don't know, the SKU or whatever, the UPC, I don't know, who cares? Some number, some field. It is the unique identifier of a thing. And in REST APIs, and I keep saying that I'm not against REST, and I'm not crazy about GraphQL. I'm more just bullish on APIs in general. But the thing is, in REST APIs, you can have fields in the URL, you can have query arguments, you can have headers, you can have so many ways to identify something. And in a federated graph, you have entities and keys, and everybody knows what we're talking about. And if you go to Hub, you can even see your entities and the keys. And the other thing, and you taught me a lot about this topic, because that's actually your domain, and I want to ask you to explain a little bit more. You can't just give a graph to an LLM and things will work out, because I think you need to do some processing and indexing, because what I learned from you, to give one example, if you name things the same way, or if you don't have descriptions that are meaningful, you can't really go from a prompt to a good query. So going from a prompt to the right REST APIs is even harder, because nobody built REST APIs for agents. REST APIs are typically built so people can either manually integrate or they can generate SDKs. The purpose is a completely different one. And just in general, how do you think a graph aligns with the requirements of a model to talk to APIs?
That's a great question. You already said, like, you usually don't design a REST API for an agent. You would usually create a new endpoint for that. In GraphQL, everything is composable, so you can add a new directive that is, the purpose is to describe that particular type for an LM. And if we talk about GraphQL Federation in general, like, all the efforts the company put into the graph is paying off at the end, because the ultimate goal of a company is to build a graph that makes sense, that encapsulates the whole company's domain. So at the end, all the efforts you put into it is paying off, because you have like a composable layer, API layer, that you can query, and that an agent can efficiently query to get only the data that it really needs to answer the question of the agent. So if you would do it with a REST API, you would need to create a new endpoint, or you would need to do create new views to reduce the context for the particular agent use case, and so on and so forth. So a lot of things that an agent today needs, like crisp data, only the data it really needs, the composability is already solved by GraphQL itself. So yeah, I hope that answered your question.
Yeah, the other part is, if you do REST API design well, I think you don't want to return cars when you go to /user. And you don't want to load comments when you go to /friends or something. What you typically do is you go to /user, and user might have friends. And then you can have different ways. You can return IDs to get friends. You can return links to get friends, like hypermedia or something. But in general, you go to /user, you get a user. And then let's say you want to get your friends and their top 3 comments and the likes of those comments. And if you do that with a REST API, you're kind of giving the model the responsibility to understand all your REST API endpoints, and to figure out, I need to go here, then there, and then there. And you kind of do these multiple round trips of fetches and kind of assembling the data, which means the execution plan of that operation, it is driven by the model. It is non-deterministic. The model fetches something and then gets something more and whatnot. And if you compare this with Federation, in Federation, this whole, where does the data come from and how does it correlate, how does it link, we solve that at build time. And then at runtime, we formulate a query. We say, give me users with posts, or give me friends with posts and likes, whatever. You formulate the query, and we have a query planner, what Sergey is building for so many years now. And the query planner is deterministic. It takes a query against the graph, and it figures out we need to fetch something from this subgraph, then there, and we combine it. So this entire process, it is deterministic. And that also means you can look into your analytics and you can see, is this query fast? Is it slow? Does it perform well? Do we have a bottleneck? So you have like a large query and it spans 5 subgraphs, and you can see in your telemetry, it's going well, it's not going well. Compare that with REST. The agent makes, I don't know, 50 API calls, but you don't really see that was one prompt. What you see is 50 API calls. Was the prompt fast? We don't know. It's
and we didn't implement that for a particular consumer, right? So there's still the GraphQL API that can be consumed by anyone. So it can be an agent, it can be just a web application, it can be iOS application. So yeah.
And the other part is, you mentioned this earlier. One of the, and honestly, for quite some time, this is like I have kind of my yeah, how do I say? I have my thoughts, you know. And for quite some time, I'm thinking, what is the most powerful thing in Federation? Or in GraphQL. If you use GraphQL for apps, then I think it is the fragment, because the fragment allows, UI components to define what they need. You compose all these fragments together. You have a query for one page. That's awesome. Kind of like relay client. But for LLMs, I think the most powerful thing is actually the selection set. You have this entire graph. It gives you everything from 1,500 REST APIs, and all you do is you define a selection set or a combination of selection sets, so a query, and it allows you to pick from the graph the things you need. And I think it is extremely powerful, because for the model, in terms of complexity, it means two things. You have an intent and you turn it into a query. You don't need to know anything about the 1,500 REST APIs. All you do is you turn it into a query. And the second part is, token have a cost, and ideally we only bring back into the context window what is actually interesting to us. And have you ever seen the REST API of GitHub? It can give you very big JSON blobs as answer. Like it has so much knowledge about a pull request or something. And if you keep going with very fine-grained fetches, it's actually quite a lot of data that you're loading, and then you have to discard almost everything. And yeah, of course, we can somehow solve this problem, and we can have, I don't know, there's things like context mode where you run curl scripts in sub-agents and then you filter everything. And with GraphQL, you just make a query and you don't even have to think about that kind of problem.
I think I also saw in several REST APIs that you also can have like a list of columns to filter data sets. But at the end, ultimately, you're coming to the point where you said, like, why not adopting a new technology? And I think GraphQL is the best technology for LLM consumption in an enterprise environment. So we're always talking about enterprise big scale scenarios. We don't talk about hello world scenarios here. So yeah.
If you don't have GraphQL Federation and you're a big enterprise and you want to expose many APIs to LLMs, what kind of problems will you have to manually solve?
I mean everything: service discovery, pagination, creating a standard around how APIs are defined, open API, documentation, and at the end, in order to create a streamlined process around this, you're building your own API platform, which everybody is doing right today. Like a lot of companies building their own API platform, and instead of just adopting maybe Hub and WunderGraph. which already solve all these problems in a standardized fashion. And now, after we released Hub, you also can collaborate, design, and governance API changes across your company, and you don't have to invent your own standards. So you can just mind your own business and buy the solution.
It also means you can learn from other companies, because we're not building Hub and Cosmo out of nowhere. Like we are the ones who are talking to and visiting big enterprise all the time, like banks, car makers, so many companies, and we see the patterns, and we kind of connect the dots, and then we're like, okay, here's Hub, and here's the next step. And of course, it's exciting to build your own API platform, and at the same time, yeah, you have to think about what
telemetry, like telemetry, observability, everything around API traffic, API governance. Like I also have a question to you. Like there's always a cost of adopting a solution, right? So if you're adopting a very opinionated solution, there's always a cost of it. So that's why a lot of people are doing it in a different approach. For example, they're starting from scratch, building their own API platform until they realize how much it actually costs to maintain and how much effort and expertise it requires to operate this for the next 10 years. So every solution has a migration cost. So, but I'm excited, to be honest. I'm really excited because we are solving that problem as well in the future. So one of the problems we have observed over the couple of years is like, how can we simplify bringing non-GraphQL APIs into the graph? And yeah, I mean, it could be a question that you should ask me, but I will ask you.
so okay, what should I ask you?
I mean,
Dustin interviewing Dustin.
Tell me how we will solve that. I will, yeah.
It's a good point. Like adopting Federation has a cost. Adopting GraphQL has a cost, but obviously, with LLMs and with what we're currently building, the cost will almost go to zero.
Yeah.
Any remarks on the topic?
No, absolutely right. Like, as everybody knows, like LLMs will solve or has solved code generation. So the next step is to how can we provide customers a service, an agent to make that transition from API, from a non-GraphQL API into a subgraph. And that is just a translation layer. It's a middleware. It's a view transformation layer, if you want to call it like this. And we were already working on the solution to make that a smooth and experience, so that you can upload an open API spec and we will transform that into a subgraph, and you don't have to maintain that transition layer anymore. And then, but you will get all the benefits of the federated graph. And I think this is huge. And yeah.
You know, I like to take risks, like not risks in the sense that they ruin the company, but we're a startup. The only way we can move forward is we need to take risks. And I think more than a year ago, it was the time when I think Cursor was the big thing. And I looked at Cursor and I asked Cursor, build me a subgraph. Build me an Apollo Federation subgraph. And it kind of couldn't fully do it. Like it did something, but it wasn't fully correct. And the issues they had to do with things like you don't have extremely strong guardrails when you create an Apollo server. Like you can have a schema and you can have resolvers, but they don't necessarily have to conform to the same contract. It's kind of like week, and I kind of realized, and I had this idea that, okay, AI is coming, and if I assume that models will only get better, there's so much investment, let's assume models get better. Code generation will get better. We can generate any code. And it was kind of the moment where I think Apollo came around the corner with Apollo connectors or Connect, or no, it's Cosmo Connect and it's Cosmo Connect and Apollo connectors. So they had these directives. And my kind of bold take was, we don't need to build connectors. What we need is, we need to build a workflow so that AI can build any subgraph or AI can connect anything. Because if code generation will be very fast, very good, high quality, what we need is a very strict contract where we ideally have like compile time checks and the compiler says yes or no. And then we have a data source that can be a REST API, SOAP, it can be a database, it can be anything. And we can just implement the resolver within AI. And I was thinking, okay, if we can have this kind of strict contract, strict boundaries, strict guardrails, and we can have AI generate the rest, then we can say, okay, here's a subgraph schema, compile that into something, and that something should be very strict. And then we say, implement the resolvers, and now we have something. And yeah, how do we call this?
Cosmo Connect.
Cosmo Connect. What is Cosmo Connect, and why does it play such a big role in the AI age? And I'd love to hear your take. How would you compare Cosmo Connect with LLMs versus directives that allow you to do REST API or HTTP API things?
I mean, if you look at how Apollo is doing that, they allow you to place directives into your schema to extend your supergraph. You need to define a target URL, headers, then you have some syntax to do some transformation for headers. And we were pretty much in agreement that this is not the approach we want to follow, because you would like to, you want to have it testable. You want to make it, you don't want to have infrastructure in your supergraph schema. So, and that's why we came up with the idea, like, how can we come up with a solution where we treat everything as a subgraph? So, but still making the experience, the developer experience, super good. So, Cosmo Connect, you need to think of is like you're starting with a subgraph schema, but from a subgraph schema, we generate an intermediate format, which is currently, in our case, the protobuf definition. And then from that point on, we just reuse regular protobuf tooling to create the stubs of that implementation. The stub is, in that case, the resolver. And then you implement the resolver, and the whole translation from inside the engine to that gRPC service is verified and done at build time. So that means we have the speed, the safety of gRPC, but we also have the type safety of gRPC. And if you know a little bit about GraphQL, maybe a little bit much, then you know that the existing GraphQL implementation subgraph frameworks are not type safe. And this also removes the whole burden of running and maintaining a subgraph framework, because subgraph frameworks are kind of complex. So by adopting Cosmo Connect, you get the benefit of a subgraph without adopting a subgraph framework. Subgraph frameworks can have security issues. Someone needs to maintain them in different multiple languages. And this is already provided by gRPC itself. So, and this is so powerful. Like, instead of dealing with directives, we thought, like, how can we make building subgraphs much, much easier? And now with LLMs, you can tell an LLM with Cloud Codes to generate a plugin and call it a day. And we have different approaches how you can actually run those subgraphs. You can let the router spawn them itself, so you don't have operational complexity in running them in parallel to the router. This is like a sidecar approach. And if you want to scale them out for scalability reasons, for team purposes, you can also run them as standalone Kubernetes service, for instance. So we have best of both worlds, and everything is just the subgraph. Also on the telemetry, on the observability side, I actually don't know how that works if you extend a service inside a supergraph schema, how that will behave on the telemetry side, because I think it requires custom instrumentation. That's what you cannot control. Yeah. Another very great side effect of it is like Cosmo has MCP support. It's an MCP gateway. That means you can build a Cosmo Connect plugin, and you can expose that schema through an MCP operation. So you can essentially build MCP capabilities, MCP services by building Cosmo Connect plugins. And this is just a side effect of treating everything as a subgraph. Yeah.
Another thing, so to implement Cosmo Connect, you need to write some code, but actually that time is gone. Claude writes the code for you. But at the same time, I think one of the big benefits of doing that approach is high quality public APIs like Stripe and others. They have very, very good SDKs. If you use, for example, AWS, you might be familiar that for some services, you need to add signatures to requests to call them. And all these kind of things, they are solved by SDKs. And if you have an environment where you can run code, you can import the SDK and just use that. And the SDKs, they are well documented. They give the model context, how to use it. And so you can just say, oh, here's this subgraph. It should pull some data from GitHub, use the GitHub SDK, authenticate, make the requests. And yeah, you don't need to think about all the details. And you can leverage the power of the SDK. Like there's big advantage.
And I think testing is often oversight. Like in our case, you can build that service in isolation and implement integration tests. And imagine what would be the opposite? Like if you would extend data sources in the supergraph, you would need to run and start the full router to test it. So in our case, we can run in-memory gRPC tests against the contract of that particular subgraph of the Cosmo Connect. And I think from a developer experience, it's huge. If your
subgraph is just directives and you have to run a router to verify it, how will you actually test it in the end? Like to test something, you need test code, right?
Yeah.
So you end up writing code anyways.
You need a mock server somehow, right? Or you want to test against production or staging, of course. But if you want to do it locally, you need to, or you're starting experimenting with a new endpoint, whatnot. You need to also some way to mock, yeah. And I think the whole setup becomes very unpleasant. Like,
so the pitch, I just have one single subgraph file with some directives. It's not really realistic in an enterprise environment.
I mean, to be fair, and also to like, it's easy to get started with. Yeah, you just put something into the schema, and if you don't have any advanced use cases, it could fit your use case, but like nothing like in software development, like you need to think of a little bit more into the future. Like it's not like I add something to a supergraph schema and this is the whole story. Like you will repeat yourself by making these mistakes over and over again, and then you add tech debt and legacy, and it becomes a mess. So you need to start very early in the process with the right architecture, and that's what we decided to do. We could also have done this. We could introduce another directive, but we decided us going the hard way to doing. We decided to go the clean way, the right way.
Do you know that I had this directive many years ago?
Yeah.
I had a gateway. It could even use WebAssembly, and it also had NAT support. And yeah, it was just 5 years ahead of everything else.
I think it even had Kafka or support and MQTT or I think everything. Yeah.
What it didn't had was users, but yeah, we kind of learned the hard way that writing code, it was never really the bottleneck in creating a business. It was more distribution.
Yeah. And creating actually value for a customer.
Yeah. Or even more important, not just creating value, but building a way where you can also capture the value. Because, just making everything open source and then there's no value capture. You also want to build a relationship with your customers where they can pay you something and they think it's fair, and you get something from them. You think it's fair, you give something back, they are very happy about that, and you have this kind of relationship, and it's a win-win situation for everybody. And that's, yeah, like, writing the code, like, not to say that your work is not important, but writing code is one thing, building a business another.
Yeah, I agree.
We are on the last minutes of the stream. Where is WunderGraph heading? What is the future of Hub and Cosmo, and where are we taking all of this? What excites you about our next steps?
I think we kind of gave an outlook in where we're heading. It's about AI. It's about agentic. It's about how can we, like today you can use LMs for any kind of code generation, very isolated way. As soon as you want to connect your modules to a system, to an enterprise system, you run into certain bottlenecks, and also in just structures that you cannot control through an LM. What we want to achieve is like, how can we enable developers in an agent workflow to implement front-end components, implement use cases automatically, figuring out what is, if the graph already provides this data. If the data is not provided, how can we propose this data in a workflow where we can propose that API change, that extension to the company, and then complete that full life cycle to enable that developer to complete their use case on their machine. So one of the big topics is how can we how can we make agents fully autonomous by implementing real end-to-end use cases. That is one big topic. The other topic is how can we democratize data access when someone has adopted the solution like WunderGraph? How can someone just talk through ChatGPT or Claude, like, please generate me a report of my current customers and analyze which customer is happy or unhappy, which problems currently needs to be addressed, and so on and so forth. And by just making a query to the graph, getting real-time data, creating a report that is shareable across the company, and these are the most exciting parts.
I am Dustin Deus. I am super excited about the future of WunderGraph. I always talk like this, but I apologize because I work so hard with all our customers. I'm a little bit tired.
I'm kind of
you have some crazy pressure. It's really impressive how you hold everything together and you still find time to go on stream. I did something very smart. I found you, and that gives me a little bit more freedom because I make you responsible for so many things. So yeah, Dustin, it was a pleasure. having you on the stream. I think what we're doing is really cool. It's great to see what you have built, what the team around you have built, and I think we're all super excited. What we also see in the market is actually starting to pull. Like the big thinkers, they are starting to realize the value of the graph and how it connects to LLMs, and yeah, I think big things are coming, and when we started, we never thought we would build such a tool for LLMs. We wanted to build it for organizations to scale, and now we kind of realize that with LLMs, organizations, they can scale even more. Like even smaller organizations, they now behave like if you have just 50 developers with AI, they can now behave like you have hundreds of agents theoretically running and trying to do tasks, and they need Jacob coordination. And so yeah, we're building coordination, we're building governance, and
They need the right guardrails.
yeah,
If you multiply 50 developers with 100 in parallel agents, yeah.
You know what was so funny? So I had to do this video, this launch video for Hub, and I did the script together with Jacob, and then I had a film crew in Frankfurt. They gave me like the script and some words that were bold, and whenever something were bold, I had like notes how to do my text, and the bold things I had to, like Jacob kind of said, I have to do like emphasis on the things, and then yeah, I never kind of did this, and it was just funny for me, like reading blah 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 coordination, and yeah, it's, I don't know if you find that funny. For me, it was just super weird because you read a sentence in like a normal way, and yeah, then you do that emphasis thing. But I have to give credit to Jacob. I think the cutting and everything, it's really great. I didn't mess up my part, so I just played my role. But I think Jacob did very well, and then the team and everybody did very well. I think the launch has really shown we have a great culture in terms of, like, I don't know, everybody's kicking ass. It's fun to work with everybody. We have one direction. I think it's very clear. And yeah, big shout out to the entire team.
I forgot, like, if you're interested in the video, like wundergraph.com/hub, that was my sentence. I had to say. So
yeah, where's your part, Jacob? What did you do?
I think it's coming soon, or will never arrive. We will see.
Tomorrow is the last day of the launch day. We will have David on the stream, or we will be roasting David on the stream. I need to come up with some very good questions, and yeah. But I think tomorrow will be super exciting, because when we started building Hub in the early days, we figured out that actually it's not going to work. We have a problem, because we thought, oh, we go from supergraph to subgraphs and we just wipe code something and it will fly. And then we realized turning composition around, it's a little bit more complicated. And so we had to build a new algorithm. This algorithm is called fission. And yeah, I think there's just one person who really understands a little bit about what fission does. And tomorrow we will talk with David about fission and how that enabled Hub to do what it does and why it's important. And so if you're a geek and if you like algorithms and if you want to see I think one of the smartest people who knows something about federation in the market or on this planet, then see you tomorrow for the next show. Thank you, Dustin, for being here. It was a great one. And yeah, have a good one, everybody.
Bye.